Hello class, I can't be with you today, so I wanted to make a screencast of the sort of problems that you're going to encounter. I'd like for you to work on these problems today and turn them into the sub before you leave class. That is due today, and I know that this is last minute, but this I had to miss today, so I do apologize. But let's go over the problems, and then you can learn how to do these. This is problem number one. I made a copy for you, and this is what the copy looks like. There's going to be A, B, C, and D. You have to do C, and 2, and 3. So what I'm going to do is I'm going to do 1A, and I'm going to show you what it's all about. This 1A, it tells you there's a concentration of hydrochloric acid, and here's the volume of hydrochloric acid. Then it mixes with the concentration of sodium hydroxide, and here's the volume of sodium hydroxide. This is what we call titration. And what happens is the acid neutralizes with the base. The base is going to neutralize the acid is going to neutralize the base. We're going to generate a salt and some water. So what does this all mean? Well, what I've done is I've provided a video that will kind of explain it. I'm going to do it when I get back to class, but I wanted to show you this here. This is the titration video, so let me show you.
A titration is a controlled acid-base neutralization reaction. 20 milliliters of hydrochloric acid of an unknown molarity is added to a flask. 2 drops of indicator dye are added to the acidic solution. This indicator dye is clear in acidic solution and pink in basic solution. The burette is filled with a sodium hydroxide solution of known strength, and an initial reading is taken. The base is added to the acidic solution until the solution stays a slightly pink color. At this endpoint, a final reading is taken. The moles of base added equal the moles of acid present. This same reaction can be followed using a pH meter instead of an indicator dye. Initially, the pH changes very little as base is added. Suddenly, the pH changes rapidly as the endpoint passes. The solution quickly becomes very basic, and again, the pH changes very little. The endpoint occurs at this middle point on the curve.
All right. So what I'm going to do is I'm going to solve the problem here. So that was a titration. It's a quick little video, but this is what's happening. We're mixing the base into the acid, or acid in this case into the base, and we want to know the concentration. There's some notes I passed out for you, and I think that you'll be able to follow along. But I'm going to solve this problem right here. So it's on your notes, so it's probably playing in front of the class right now. So let's do this. All right. So the first thing you need to do is you need to set up, and this is problem number 1A, and you need to set up a reaction. So like I said, it's HCl, hydrochloric acid, and we're going to mix it with sodium hydroxide. This is called a neutralization reaction. And what he said is the endpoint reaches when the moles of acid and moles of base have been reached. They are equal to each other. So what happens, and so I'm going to kind of break it down for you. So these things, these bonds, they cleave and we make ions. Remember that? We make an H plus 1 ion and a Cl minus 1 ion. And then we also on the sodium hydroxide, we make a sodium ion, and we also make a hydroxide ion. And so what they're going to do is they're going to trade partners. So in other words, sodium's going to grab chlorine, and then this H plus ion is going to grab hydroxide. And that will be our products. So if I rewrite this, it looks like this. It looks like this. HCl plus sodium hydroxide yields Na, and there's a plus 1, and then there's a Cl minus 1. And then it also gives us H plus 1, and then a hydroxide minus 1. Alright, so then remember, use the charges to balance them out, and then you should end up, and I'll rewrite it once again, HCl plus sodium hydroxide gives us a salt, sodium chloride, and water, HOH or H2O, however you want to write it. So now I'm just going to look, and I'm going to balance it across. Remember, there's one H here, one H here, one chlorine here, one chlorine here, one sodium here, one sodium here, one OH here, one OH here. It's very simple. This one's easy, of course, but some are much more difficult, so please take your time. Those coefficients are key to these problems. So let me write down the information that we're given in this problem. It said that there is a 0.25 molar HCl, and that it has a volume of 30 milliliters. Now remember, moles are in decimeters cubed, so I need to change this 30, this is a 30, believe it or not, change it to decimeters cubed. So I need to convert it, so it's going to be, remember, move the decimal to the left 3 spaces and it becomes 0.0300, excuse me, decimeter cubed. Alright, and then for the sodium hydroxide, we don't know what the concentration is, and that's what we're trying to solve for. But it does give us a 25.00 milliliter volume. Now, same thing here. I need to convert that to decimeters cubed as well, 0.0250 decimeters cubed. And I have all the information. So once again, you should balance the reaction first, write down your information, find out what you're looking for, and here's what I'm trying to solve for. I need that molarity. So how do we do this? Well, I have so much information on my hydrochloric acid, so I start with that, and this is what it looks like. It's 0.250 moles, remember molarity is moles, per decimeter cubed of HCl. Okay, so now I'm going to multiply by the volume. Remember, if I multiply by the volume, a molarity times the volume, and I think that's in your notes, it tells you the molarity times volume gives me moles, and here's why. This is decimeters cubed all over 1. Decimeters cubed cancels out. And there you have it. I have moles of HCl. All right, so now I have moles of HCl. At this point, once you get moles, remember you can transition. So it tells me here I have moles of HCl. I need moles of sodium hydroxide. And there's a 1 in front of each one, so I'm going to convert. Remember, this is the mole to mole ratio. So I need 1 mole, remember what I want, over what I have. And then over 1 mole of HCl. Remember, these are the coefficients. This 1 right here is the coefficient that is right here. This 1 is the coefficient right here. And so if you have a 2 or a 3 or some other number other than 1, it would go at that spot. So now my moles of HCl go away here. Now I have moles of sodium hydroxide, and all I need is a molarity. So once I have moles, I'm going to have 1 over the volume, right there, the volume of NaOH. So it's 0.0250 decimeters cubed. All right, so if you did all the math, and remember, you should end up with moles per decimeter cubed as your units, and you should end up with the 0.300 molar sodium hydroxide. That's how you would find out the concentration of an acid or a base, in this case here, of a base. And that is titration. Those are your problems for today. I hope this video helps out. If you have any other questions, we can answer them on Friday before the weekend. I hope this all works well for you. I'll talk to you soon. Take care.